I'm rolling.
You are?
Oh, are you ready?
Okay. Well, we'll start now.
Okay.
Alright, so this is the rotary evaporator. Short is Rotavap. So if I say you just use the Rotavap, this is what it is. It's going to be used to evaporate solvents. It's the organic chemist tool for doing that. This is the vacuum pump. It's really a water aspirator, vacuum aspirator. And it'll pull a vacuum through Bernoulli's principle. So if I turn this on, there's a switch in the back. Now, through the hose, we are sucking air. It's actually coming from here right now. This is where you're going to put your flask that has the solvent you want to evaporate. So the proper procedure is actually prepare your flask. This is called a bump trap. Often when you're evaporating solvent, it will boil up. You don't want the solvent to go into the machine, so you use this as a trap to prevent liquid from getting to the machine. These are special flasks. Notice the shape. They're thick-walled. They can hold a vacuum without cracking. So these are the Rotavap flasks. As you use a Rotavap flask, it has this shape. It's not round. It will attach here, and you need to clip it, otherwise it falls. So we have these clamps and these clamps. Depending on the size of flask, you use the proper sized clamp. This is called a keck clamp, K-E-C-K. I'm snapping it on. Now, it's not going to fall. The Rotavap itself is called rotary because if I turn this dial, the flask will spin. A good speed is about 100 RPM, but you can see I can make it faster if I want to. So, the other control is the temperature of this bath. It's a water bath. Right now I've got it set at about 50 degrees Celsius. Depending on your solvent, that may be appropriate. If you're boiling off dichloromethane, you don't want any heat here at all because dichloromethane is really, really easy to evaporate. For ethanol, 40-something is a good temperature, so I'm happy with this. Now, that's spinning. I'm going to pull my vacuum. So I turn on this switch in the back. Pump is going, and I am pulling a vacuum now. You can see the dial turning here. Atmospheric pressure is 760 millimeters. So this is not really the atmospheric pressure, it's how much vacuum you have. If I got it all the way to 760, I'd have zero pressure inside. But you can't get that low, but you want to be between the 700 and the 760. That means your vacuum is good. So, this is under vacuum now. I want to put it into the water to heat it. This says push. I push and slide, and the whole apparatus will lower. So I'm not completely submerging the flask, but you can see the part that has solvent is in the water bath. A little bit lower is probably good. That's perfect. This has to have ice in it. If you're using dichloromethane, it has to have dry ice, so we'll get a film of that in a few minutes when Curtis comes back with the dry ice. But I put ice from the freezer. Ice from the freezer. I put cubes into the trap. I added a little bit of tap water. You have to keep your eye on that. If the ice is all melted, you need to add more ice. Now it should be that the warm solvent under vacuum starts evaporating. The vapors come up here. They condense to liquid. It's dripping now, so you want to get a close-up of that. That's the ethanol in the flask condensing right here. So this is how it should look when it's working well. You can evaporate your solvent quite rapidly. In the end, this is going to be waste. I'll dispose of this in the organic waste vessel. This is you can see the vacuum now. That's good. That's the way it should look. We'll pretend this is done. It's not really done. I need to release the vacuum. So this is the knob that allows you to release the vacuum. You can hear the hissing sound as air goes in. Now I can turn off the pump. Never turn off the pump while there's still a vacuum here. Now I can raise my flask out of the liquid out of the water bath. I can turn off the rotation. I can remove the clamp. Holding the flask, because nothing's holding it now, it can fall. And normally you would evaporate to dryness. This, I just cut it off early. But normally you would say it's all done. This also has a clamp, snap, and you can remove the bump trap. The Rotavap flask and bump trap should live right here. To remove the trap, you have to turn the knurled nut, and then you can pinch this and you are able to remove the trap. Opposite procedure for putting it back on.
Hey Nick, how much longer are you going to leave that for?
Okay, that's the use of the Rotavap. In the end, you want to turn off the water bath. There's no reason to keep it hot if nobody needs it to be hot.
If you're using a smaller flask, you're going to have to use an adapter. And you can just put that on the end of the trap.
How do we wash this? We just shoot that out.
Attach that with a clamp. Hold on. Got it. And then attach that smaller one. And there you go. If you're using dichloromethane, you need to use dry ice, and that's what it should look like. It should be bubbling vigorously, and you can see how fast the condensation is coming off into the waste.
I would say that